Yeah, welcome to Code Club. Um, John told me to pick some code to look at today, so I've built web APIs as part of work. That's something I'm still doing at work. And one of the things I was curious about understanding better was the context package, because I've seen a lot of people talk about not talk about how it works, and also a lot of people seem to have strong opinions about whether it's even a good or bad package to use at all. But I didn't really understand it at first when I was learning how to do Golang, and I still want to understand it better. So I thought maybe we could look at that package, and I found some code that uses it, and we can maybe try to see how it works within that code base.
Sounds good. Perhaps you should just briefly introduce what context is and what it's for, in case anybody doesn't know. Perhaps they don't.
Okay. Well, I'll explain it to the best that I understand it, and that's part of why I wanted to do this. But so primarily what I've seen people use context for is web APIs. And the idea of it, to my understanding, is it's something you use for request scoped situations, meaning like, API call coming into a web server. One of the main ways people use it is to create an ability to, I guess, track the flow of that request through various functions and cancel the go routines that are created if maybe you have one of the, I guess, common examples is like maybe you have an endpoint that ends up making a database call or something, and maybe that's timing out or there's something wrong with it. You can use context to set up like a timeout value so that regardless of like what's happening within the code, if you hit a certain timeout, you can just shut down the process that's happening. So yeah, I mean, John, I don't know if you have a better explanation.
I think you pretty much nailed it.
Okay. So I wanted to go through the package itself a little bit. It's pretty small. It looks like there's really only a handful of things that it's intended to do, and that's one of the things that I've heard people say is it's by design kind of limited in what you should be trying to do with it, and you should avoid like passing variables into it and stuff like that. But there is an aspect of it where you can add a little bit of information using this with value function. And one of the things that I've seen for that is, for example, like because it's a request scoped, it's meant to be. My understanding is its life cycle is meant to exist within the context and like the life cycle of a single like API request and response, basically. So one of the things people use the with value function for is to like track the IP address of someone making a request. So you have that information maybe to log it or something.
Yeah, just a footnote to that is we've probably all come across context just by the fact that we have to pass them to certain APIs, like
right.
DBs, or like, Mongo needs a context if you open a Mongo client, and might have wondered what that's for, because you can just call context.background to get a sort of blank context and pass it. And basically it's, as you said, for things which either need to be cancelled or timed out for some long running operation which could fail.
Yeah, I come up with one example these days, like Terraform use this for timing out in the resource creation. So like when you talk to the API, you use this context to set like how many times Terraform will be waiting until the API responds.
Mm-hmm.
Yeah, exactly. And since, web request handlers are obviously one of those situations where you could be doing something and you need to pass the cancelability on to everybody that you call so that they can pass it on to the people that they call, so that when you know, whatever it is that's going to get cancelled, we'll be able to receive that signal. And so one thing that's sort of been tacked onto it is, since you have this little thing that you're passing through the entire request chain, somebody must have thought, why don't we store arbitrary key value information on it, right? Since we have this thing, and it's difficult to otherwise pass that stuff around from handler to handler. So there is this tendency to use it as a kind of a catch-all place to stuff information like user ID, tokens, cookies, all of that kind of thing.
Right. And I've seen a lot of people sharing the opinion that you need to be very careful with doing that. And I don't totally understand why they say that, but it seems to be a common thing that you need to limit how you use context. But so anyway, context is an interface. So that's defined here, and it has a function here called deadline, which I guess allows you to set. Sorry, I got I got sick this week, so I'm a little congested. So this generates a channel. Well, okay. This is part that I'm sort of trying to understand, but I know the context makes use of channels and sort of the simple signaling mechanism you can do. Here, calling done and sending a message onto a channel, and so I think this is the sort of basic channel mechanism they use to signal the shutdown based on whatever it is you decide that needs to be. So,
yeah, I think we touched on done channels briefly in the session on the chat server, didn't we?
Right.
Oh, and maybe also the parallel downloader. So, like, since a lot of what we do is just listening to various channels for things to happen, if we need to be cancelled or timed out, there needs to be some channel-based way of sending that, doesn't there?
Right. And one of the things that the description discusses is that the context can be passed to functions running in different Go routines, and contexts are safe for simultaneous use by multiple Go routines. So, and that is one of the things about it that the interesting thing about it is they sort of have these like rules that you need to observe and how you use it. And one of them is that you don't add context onto a struct field that you've made. You're supposed to explicitly pass it around from function to function. And
oh dear, I think I've done that.
It says
I second that too.
It says you are not to do that. Absolutely. So I think I don't know why it doesn't. I don't see in here where it goes into detail about why you're not supposed to do that. But I think it may be. I don't know. Maybe I shouldn't speculate. But like John was saying, a lot of libraries will have a context argument for a lot of their functions, and it's always typically always the first argument that you see passed in. And this is sort of a pattern they recommend in this library.
Yeah, maybe that's one reason why you're supposed to do that, is if you just got some struct, you might not even know that there was a context on it, or that you need to pass that on to anyone you call.
So that was my assumption, was like forcing you to be explicit about it so you don't lose track of it or something. Because it's supposed to, what it's supposed to do is like, it's supposed to be able to pass from function to function, and each time generates like a child context based on the parent, is my understanding. And so like a child can be canceled by a parent context, but I don't think it happens in the reverse. I don't know if you know that, but they have a blog about this that goes back to, I think, 2013, 2014. So this is something that's been around for a while, I guess, and Go.
Yeah, one weird thing is, sorry, go ahead.
I was, so this not passing it into a struct, and passing it explicitly to functions is that's interesting. Now I have to refactor some code.
Yeah.
Yeah, and I wish I don't know, but I'm sure someone has written more extensively about why they recommend that, but they're pretty, they do recommend it.
Yeah, and
And
one more point about the blog is just that often you see a really great blog.golang.org post which explains something really important, but it's from years ago.
yeah,
Like as you said, this is 6 years old, and sometimes people say, you know, is that not out of date then? Because with anything else it would be, but with Go, no, it just hasn't changed.
yeah.
Which is one of the nice things, isn't it?
Well, could it be also, I mean, so when you define, you know, when you define something like a context in a struct, and you call maybe into that package, you have, if that package is exportable, or that struct is exportable, you can use those values somewhere that they shouldn't be used. Maybe like I don't know. I'm trying to think of a reason why I wouldn't do that. So why I shouldn't do that.
Yeah, I don't know. So yeah, and one of the things that they mention also is you should never have a nil context anywhere, because I guess a context can be nil because it's an interface, but they recommend not to do that. So if you have a context, if you want to pass a context in and you don't know what to do with it right now, or you don't know really what you want it to be, they have this kind of funky thing, this function called to do. That's meant to remind you that like you put a context here and you need to go back and figure out what you're using it for. So I thought that was kind of odd, but interesting. You can use background or to do to initialize a non-nil empty context wherever you might need it. So
yeah, so it's exactly the same as context background, but it's just its name indicates that you're not done yet.
yeah.
You're going to use something else. And if you're the type of person who puts to do in your code all over the place to remind you about bits you haven't done, which you definitely shouldn't do. But if you do do that.
Right. And I think, let's see, there was
Do a search on to do on GitHub sometime. The results are amusing.
yeah.
It's basically 100 million things that people forgot to do.
I thought maybe we did just look at this most basic example they give here. This is an example of a Go routine that would generate integers in a separate, a function that generates integers in a separate Go routine and sends them onto a channel. And we want to cancel the context when it's done consuming the integers. And the idea of canceling the context, I guess, is to avoid leaking the Go routine that was created. So this function takes a context, and you can see down, let's see, down, where do we call this? Yeah, so down here where we call the function, they initialize a empty context that has a with cancel, let's see, let's look at the with cancel. There we go. Yeah, so the function with cancel takes the context and returns you another context and a cancel func, which is what you call to actually to do that cancel. So I noticed this pattern sort of is ubiquitous with the context. Is you pass a context into something and it returns you a new context with maybe something on it that you want to use. So this context with cancel takes this sort of basic context that has nothing in it and returns this cancel func that you can use.
And it's a nice pattern in general, isn't it? Anytime you're creating some sort of resource that needs to be cleaned up, you can return a cleanup function along with it.
Yeah, so all that seems to be happening here is they're just getting that cancel func and then deferring it, and then let your function run, and then you'll know that you'll be sure that Go routine will get killed once all this is done. So yeah, it seems like a useful thing there. So I thought maybe so this is from Arden Labs, which has some really good Go training. They have this library called Service, and it's designed to be like a starter kit for people that are building web APIs in Go, and they encourage people to use it and not. I think, as far as I know, not even worry about attribution and stuff. It's meant to be like for the community or whatever to help people. So it's got a nice.
Shout out to Bill Kennedy and Arden Labs.
Yeah, they're great. Their training is very good. I've done a little bit of it. So I pulled this down. Let's see. And I thought we could kind of try to trace how the context package is used here, because I guess, a big part of context is it gets passed through multiple function calls, right? So I thought maybe we could try to trace how it's used in this library.
You go up a couple of font sizes here.
Yeah, let's see. Let's see.
Command Shift plus.
Yeah, just okay. Better?
Maybe one more.
How's that?
Yeah, that's probably good.
Okay. So this is a web API. This is
All right. And if you could, once you finish pulling up your files, if you could close the sidebar, we could see more of the code.
Yeah. I wanted to show the file structure over here is interesting. He's sort of Bill Kennedy sort of opinionated on how to structure things, so it's interesting to look at how they do it here. But this is a basic web service. You can kind of see func main just calls this run function, which has a bunch of configuration that gets fired up, sets up your database and all this stuff. Start your app here. It's nicely commented. This is setting up keys for like authentication. Starting your database with all your configuration. This is tracing, which I don't know a lot about, but is it's important for testing and keeping track of web APIs.
It's open telemetry project that implements the Zipkin. It's pretty nice.
Yeah. Open telemetry. I think it may be a Google project or something, but I could be wrong about that. But yeah, it's this Zipkin thing makes use of that. So it seems to be pretty cool. It's got a lot of functionality. Start your API service. And then, so I did a find here. Yeah, it seems like here the only place I see that they're using it in this main in the entry point to the project is to do the pattern basically that we just saw. So we create a context with a timeout, takes an empty context as I guess that's the parent context, right? And it returns a child context and a cancel func. And then this must be the value of the timeout. Yeah, it's a duration value.
Yeah, so with timeout takes a time.duration and with deadline takes a time.time. Is that how it works?
Let's
like you could say with deadline midnight or with timeout 10 minutes or something.
With timeout takes a duration. With deadline takes a time. Yeah, so that seems to be the distinction, just like you said. So they're doing a with timeout, and it looks like it's defined up here.
If you wanted timeout and cancel, for example, would you just wrap those in successive calls? So you say context with timeout, context with cancel.
So my understanding of everything is that what you always do is like feed whatever your current context is in as a parent and get back like a child context with the new thing added. So I
But
don't know.
with timeout returns with deadline already, no?
Okay, so
Oh, yeah,
you
that
can
makes sense,
call
doesn't it?
because
Yeah.
the context has a deadline. Is that what you're saying? Or
Actually, I just read the description and they are saying that, to be honest. If
So
you
is it
go,
just that with
yeah,
timeout is just sort of sugar for calling with deadline with now plus X minutes or whatever?
oh, interesting.
That's kind of
But
neat.
would that, okay, yeah.
But yeah, it sounds like what you're saying is you just keep on wrapping your context with more sort of mix-ins that you want.
Yeah, I think so. I think so anyway. And then so this is being used for their little listener to do like a shutdown. Let's see if we can find this. Is this what I want to be looking at? Okay, so yeah, so this is well, this is an interesting piece of code. So let's see. See, this is pretty complicated. So
If you don't understand it, just nominate someone else to explain
I
it.
was going to say, does anyone want to take a crack at describing this this shutdown function here? So let's see, it's taking a server.
I can try.
Okay.
So basically, it's setting a state to say that the application is being shut down. So the shutdown process has started. And then it set a mutex lock. And then it calls the function close listener lock it. That I don't know what it does. Okay, there is no helper.
Why does serve.in shutdown have a set true method, by the way? Why don't we just assign it true? So you've got a mutex or something.
Yeah, that's a good question. Can you open this function? Because
It's atomic. So
yeah.
That's another way of making it concurrency safe without using a mutex, isn't it?
Mm-hmm. Yeah.
Okay. Would you mind explaining that?
Yeah. Can someone explain exactly what you mean by that?
Just because, if you have some piece of shared data between lots of Go routines, you would get a data race if you didn't do something to protect it. So one protection could be a mutex. You have to obtain that mutex lock before you modify it. The other way is most CPUs have hardware instructions to atomically modify some piece of memory by atomic. I mean, it can't be interrupted during that operation. So you can't get a data race. It's going to do everything it needs to do. And then only then will someone else be able to use the CPU for something else. So Go will take advantage of that where it's available. And if not, I think they probably just use a mutex.
Yeah.
They just
Go ahead.
Oh, so they just created a little type here that they could use some atomic functions on. Is that what you're saying?
Yeah.
Yeah. Okay.
But
It's a bit like that. Do you remember that? Sorry.
Sorry.
I was just going to say, do you remember that legendary code club where we spent the whole time talking about one line? And it was an atomic something. It was in Cockroach DB. So again, protecting a map of DB handles and round robining around it. And they used atomic add to increment that index.
And he created this function basically just to make it readability better, because he could also use directly, right? The atomic function.
I guess there's not an atomic .store bool.
Oh, okay.
You know, if they were, I expect you would have used it.
Yeah. Okay.
But yeah, I think that's exactly right. It's just an atomic ball.
Gotta figure out. You know how to open, go to a piece of code without, like, in a new window? Because I lose where I was. I can't remember.
You can use Control minus to return to the previous file.
Okay, great. Thank you.
You should thank John because he teach me this past week.
Somebody else told me that beforehand. So.
That's great. Yeah, I do this a lot, and it's very frustrating because, yeah. Okay, so do you want to continue? Pick up wherever we just got derailed.
Yeah. So. That's weird because that function close read listeners locked returns an error, and he's not handling the error anywhere. Like he's associating the. Oh no. Okay, no, he's using it over there in the for loop. Okay, so never mind.
What does the hover doc say for closed listeners locked?
There is no docs.
Oh.
Yeah.
I'd show.
You want me to look at this?
Yeah.
Okay.
So we just go all the listeners and close it. Okay. And they just call the close method in the ln pointer, which is listener. And then if the error is new, it returns the, I don't know what this function returns, the close method.
So it looks like if any of them return an error from being closed, then we at least return one of those errors, the last one.
But I don't understand why error is new equals new.
I think it's saying if the close method returned error and we don't already have an error set our error to be that error. So that when we return our error, it's, you know, if none of them returned error, we return nil. But if any of them did, we return the error that the last one of them to return error returned.
But
that makes sense.
He declares the error as an empty error. Okay, but there is a for loop. Okay, gotcha. Yeah. Okay, so we just try to close all the listeners in these functions, in this function, so we can return to the other, and then it calls on shutdown and start a Go routine. I don't know what's on shutdown. It's an array of functions, so.
Yeah, that's kind of neat, isn't it?
Where it's taking those atomic functions in, or all of the.
Our server struct he has that does a bunch of stuff on it.
It looks like you can sort of register a bunch of functions to say, call me when you shut down.
This is the shutdown that we were using. This is the listeners thing we were using. It says net listener. Okay. Pointer. Mutex.
Yeah, and I love this behavior in Go, just being able to pass functions around. Like, here's a cancel function, call it when you want to cancel. Give me a bunch of functions and I will run them when I shut down, that kind of thing. That's really nice.
Yeah, now the mutex makes sense for me because he's starting several Go routines.
And they're all called concurrently as well.
Yeah. And then he creates a new ticker for the how many time it should like wait for the shutdown or no. Okay, it's going to check if it's okay. So this is basically an interval. Like he's going to keep checking if everything is closed before hitting the timeout, I would say. And then it's called a stop function that should exit from this entire function.
So what's serve.close idle comms?
Those are idle connections. Reports whether the server is quiescent.
Oh, right. So that's basically saying that returns a bool, which if it's true, then
yeah,
the server is now idle. So everybody has been closed. So we're saying loop forever. If the server is idle and the number of listeners is 0, we're done. Otherwise, keep on looping.
Yeah, basically.
But don't loop 200 million times a second. Just, this is the equivalent of sleep X milliseconds, isn't it? The time dot ticker just sends you a message on that channel every interval seconds.
Yeah. Just don't burst my CPU.
So at this point, it's watching for a context.done to be sent onto a channel, right? So is that a situation where that would be called elsewhere by some other function that's been passed to context, or?
Yeah, if anybody's not familiar with the for select loop, by the way, we talked about that in the episode on the chat server. I'll try and put a link in the video to that.
I don't understand why you would need to do this if you're explicitly defining context and functions. I mean, wouldn't the context have already been used if the function was called and moved on? Understand what I'm saying is, why do you need a select case for closing out the context?
Yeah, well, I think it's, as we were saying earlier, if you're doing stuff that involves listening to channels, and someone wants to cancel you or time you out using your context, or you hit your deadline, you'll need to be listening to that channel. So a select statement is
So I guess I was thinking about this incorrectly then. I was thinking there are multiple uses of the context at one time. Sure, yeah, I see what. So while you're working within this context and you're trying to cancel me, I'm going to hold on to my connection until I'm done, and then let you know and move forward. Right.
Yeah, well, this is the thing, isn't it? That we were saying, if you start with a top level context that then gets passed all the way through whatever you're doing, and other contexts can inherit from it, and if so that you can just call one cancel function and you just cancel everything in the whole world simultaneously. Sure. And so everybody who's doing stuff, which might take a while, then you might be cancelled during that process. So you better make sure you're listening to the ctx.done channel. Otherwise, you won't know that you've been cancelled.
Yeah, this done doesn't mean that this operation is done. It means that your context is done. It was cancelled or timed out, right?
Right, logging to see if it's done or not, and then reporting to the rest of the field.
Yeah, what's CTX error, by the way? I don't think
Yeah.
is that just if there's any error at some point using the context.
Right. So this is one of the handful of fields that the context interface has. It says, so if done is closed, error returns a non-nil error explaining why.
Oh, I get it. That's neat, isn't it?
You see in the done comment, done channel for cancellation. So this done is not even, it's not okay, it's done. Like the cancellation happened in this context. That's my understanding. Maybe I'm missing something.
Well, let's see. So this is where this particular function is actually being called. So it's, I see. So this is like waiting. If we get any kind of errors, it's checking for lots of different types of errors that would suggest we should shut down, basically, is what I'm getting. And then if you see any of those errors, it calls this close thing. Yeah, so this is, oh, I see. So this is like if you fail to close gracefully.
Yeah, like it's a hard close. It's like a Q -9 in the process. So.
Interesting. So this is, I got it. So this is like in the case that this shutdown just doesn't work for some reason, that you're getting some kind of error, right? Is that what we're saying?
Yeah, it looks like the thing about servers, which we all end up writing fairly often, is once you start them, there's basically nothing for them to do except wait to finish, right? You know, you start all your concurrent listeners and connection handlers and whatever, but you as the main go routine don't really have anything to do except to say, are we done yet? So we're just in this select, which is just going to block, because it's not a for select. It's just select, it's just going to block on all these channels until something happens. So if we get something on the server errors channel, we return that. If we get something on the shutdown channel, now it's time for us to shut down. So we're going to create this context with timeout, with the shutdown timeout. And then we're going to call API shutdown, pass it that context, and say, you know, well, if you return nil, then everything's cool, so we just exit. But if you return some error, that means we failed to shut down somehow. So we just say, sorry, problem shutting down.
Right.
It's shutdowns within shutdowns.
Yeah, yeah. Well, so I think context will also be used. Let's see.
By the way, anybody whose project is to write an API, you're not allowed to just steal this code.
Well, I think he says that you are allowed to steal this code. That's what
I mean, you're allowed by him to do that, but just not by me.
Oh,
Josh is like, well, I think I want to.
Yeah.
Well, no, I took his little course about this, and he encouraged people to just straight up take it. So
yeah, absolutely. The point is, you should know how to do this yourself.
Fair point. Yeah,
shouldn't you? And then you can use Bill's beautiful, well-documented code in your actual app.
I think that's right. Yeah, yeah. Okay, I don't know. There's obviously lots of other places where context is going to be used in this. Do you want me to just choose some at random, and we can try to figure out if we can understand it, or?
I think we're likely to have some questions as well, aren't we?
I don't know. Well, I don't know. I mean, John, do you, like I said, I had heard people that don't even like the context, don't like using it at all, or think it's maybe needs to be replaced with something better. Do you have any like thoughts about that?
Yeah, well, I suppose, it's worth saying context is relatively recent in Go terms. It wasn't around in the beginning, and people just implemented their own homebrew solutions to the problem of canceling stuff, usually along similar sort of lines. But evidently the Go team felt it would be nice to have some standard way to do this because it's such a standard problem, right?
Right.
So they invented this context package, and that's good. We've now got a standard library way of doing anything that needs a timeout or a deadline or whatever. You don't have to implement all of that channel stuff yourself. It's just done for you. One issue with that is, as we were saying, the whole point of it is to be viral, isn't it? Once you've got one, you have to pass it to everybody you call, and they have to pass it to everybody they call. Otherwise, you could have someone who's doing something and they get cancelled, but they're just not listening because they haven't got the context to listen to.
Right.
So it does kind of ugly up your code a little bit, just having to pass the CTX around everywhere. And I think we just kind of get used to it, don't we? Just like, yep, get the CTX, pass on the CTX. We just sort of mentally tune it out. But it is annoying if you've gone to a lot of trouble to refine your API to the point where it just takes one parameter for the whole thing to work, and you're like, oh yeah, and a context.
Right.
It's a little annoying. So I see some people who just, the first thing they do when they look at a piece of code is just go, right, let's add context everywhere. I read a post on Medium that was best practice. So I'm just going to stick in CTXs everywhere, even though I don't really have a need for them. I think that's probably a mistake, or needs a bit more justification, doesn't it? I think you actually need to have a use case where you say, yeah, we actually need to cancel this thing in this specific circumstance. That's just my opinion, though. I'm sure lots of people say, no, you should have contexts all over the place, whether you need it or not. It's just a thing.
Yeah, I think this code base kind of uses it all the ways you typically use it. So this one looks like it's for timing out a database call. So you create a context here with a timeout, which gives you back that cancel func, and you defer it, and it looks like they want a timeout if they don't get anything back within 5 seconds.
Yeah.
And then that gets passed into the query, which, let's see, this is going to end up being a database call. I guess this is, let's see what's going on.
My standard pieces of advice about anything is, one, don't do it. If you must do it, use a completely standard way of doing it, ideally the standard library. And 3, if you can't do that and you must implement it yourself, implement it in the dumbest, most obvious, simple and boring way you possibly could.
This is kind of an interesting thing going on here. So the context was passed in, and then he's passing it again into this thing.
Yeah, that's a good point, isn't it? Distributed tracing is one thing that we didn't mention as a use for contexts. And if you think about trying to trace the path of a request through some complicated chain of handlers and middlewares, that's difficult. Like, you can say, oh, I'm seeing a lot of errors on my API, and I see those things in the logs, but what request caused the error, and what was the specific URI that was hit? What were the headers of the request? What were they doing? I need to know that stuff, and it's really difficult. When the error is not the error is being thrown somewhere else. So one thing you could do is you could say, attach some unique value to every request that follows it all the way through the chain.
Right. And this is that open telemetry thing. Sorry, go ahead.
Yeah. Well, that's what I was just going to say. We have that. So if we're already passing the context around, let's use that. So I guess this is how the tracing library works, is that it...
And this looks like an example of what we talked about, wrapping a context that's already been created. So what we already created this context with a timeout. So we're using it to time out this database call after 5 seconds, but we're also taking it and passing it in again to another call to do this tracing, to do this tracing thing with it. So
yeah, and most often what you want to do with tracing is you want to say, how long did this specific thing take? Like, how long did my database query take? Because if that's super long, that may be my problem. So that means, a span is basically like, I started the query at time X, I finished it at time Y. Now you can go look in your tracing data and say, show me all queries which took longer than a second.
Or look at a graph of all calls in the chain and see, hey, I know this thing is taking a long time. What part of it is taking a long time?
Yeah, exactly. So like, if you said, oh, your web request took 20 seconds, yeah, great, but which bit? Was it the DNS lookup, or getting the TCP connection, or sending the request, or receiving the request, or what? So yeah, Tom's right. You want to break that down into a pipeline to say, what's my timings for each thing that I'm doing? So we're basically saying here, start timing, defer, stop timing.
yeah, and this is the actual database call down here, and in all those database libraries, like John mentioned earlier, a lot of the stuff there will take a context as well. So that seems to be what's happening here. So this seems to be another pretty standard way that context is used. I think there's another place in the code where they do the with value thing. Yeah.
Yeah, that's interesting, isn't it?
So yeah, I remember him talking about this. So one of the things, so I think this was one of the areas where he said I don't want to misstate it because I may be remembering it wrong, but I think this was an area where he was talking about context being a little tricky because he says you have to be careful to handle the case where there's some context value that you expected to have been set and it wasn't set for some reason.
Yeah, well, that's the danger with a completely arbitrary key value database, isn't it? Is one, you don't know what keys are in there, and two, you don't know what type the values are. So, there's no accepted convention for any of this stuff, and it's not built into the context library. It's the Wild West out there. It's just a map of string to empty interface, or empty.
It seems odd to me that it's because it's empty interface to empty interface, right? A map of empty. It's not string to empty interface,
right.
Is it?
Yes, it's even worse. So you don't even know what type the keys are. So you're going to have to do a whole bunch of safety checking,
Yeah, and there's actually
assert the type of the value and all of this other stuff. So it's very awkward to use. It's like handling radioactive material with those massive Waldo gloves.
Yeah, and I think this is one of those places where they encourage you to create a type that's basically just use the number 1, but make it its own type to ensure that you don't mess up the typing aspect of that.
Yeah, so you might create a key called user ID, for example,
yeah.
But maybe somebody else somewhere is using user ID for their own purposes, and it's completely different.
So you need to make sure it's like namespaced with the package or whatever, so you don't yeah, you don't get that crossover where someone else uses the same key that's would be very common, like user ID or something like that.
Yeah, I've seen people do things like sort of prepend all their keys with their domain name or something, like backwards, like, you know, com dot whatever dot whatever, sort of just like back in Java XML days.
Yeah, and it looks like here we're this is kind of circling back to what we were looking at earlier. It's attempting to run a graceful shutdown if you have this case where this check for a value doesn't return anything. Because I guess the idea is there should be something here, and if not, the program should shut down. So yeah, so I don't know. It seems like maybe we're at time. Or at least I think I am. An hour is what we block out, right?
Yep.
Okay. Yeah. So, but I think those are all like the main ways that it's used, or that I've seen it used. So anyway, we're good. All right, I'm going to stop sharing.
Yeah, very good roundup, I think.
Cool.
It was mighty interesting, and thanks very much to Josh for hosting.
Yeah,
Yeah,
for
no
sure.
problem.
That was very interesting.
Great. All right, cool. Well, I'll see you all around.
See you next time.
All right. Bye.